So yesterday, I had asked you guys to go find real-life examples of a certain shape. Right? And whenever we graph anything, we are always graphing a relation. Why? Because it's a relationship between two variables. And we use an XY coordinate grid to graph because that's two variables, X and Y. Okay? And there's all sorts of different types of relations that we could graph. The big one, oh, sorry, I won't say that yet. I'll get to that down here. Anyway, so we looked at relations last year in grade 10. We also looked at a special type of relation called a function. What was the difference between the two? Well, a function is a type of relation. It's an example of a relation where for every x value, there's only one y value. So like if we had a set of ordered pairs, this would be a relation. And it would also be a function. Because for the x value 1, there's only one y value, 2. For the x value 3, there's only one y value in the whole set. If I added another one, like this, that's not a function. Because the x value 1 has more than one y value. There was a way I got you guys to remember it. Do you remember the phrase that you used? How you can tell if something is not a function or something is a function? Something never.
We can't draw.
Oh, that's vertical line test. I know where you're going with that. You're right. Something never repeats. Domain never repeats. Remember, domain just represents the x values in a relation. We're going to talk about that again in this lesson. Domain never repeats. That's how we remember it, really, rather than trying to put this big jumble of words here. Okay. So last year, we focused on linear functions. Why do we call them linear functions? Because every single one of them is a function, except for a vertical line. And when you graph them, they form a line. So that was last year. That was the big focus last year, and this was the big formula we used last year to help us, y equals mx plus b. Okay. Now we are going to focus on something called quadratic functions. How can you tell if a function is quadratic? It has an x squared in it. So last year when we did lines, they were always y equals 2x plus 3. Y equals negative a quarter x minus 2. Y equals 3x. Y equals 4. X equals 5. Okay? These ones this year, we're going to have y equals, and then we're going to have, we might have an x, but we're going to have an x squared in there. But the graph, which you guys were finding examples of yesterday, is called a parabola. So what does the most basic parabola look like? The most basic parabola is the equation, and remember, this is function notation. This just means the same as y. Y and f of x mean the same thing. Because this just says it's a relation, this says it's also a function. So whenever you see f of x, just think y. We'll probably make it easier. So the most basic one is just when we have x squared on the other side. Nothing else. No number in front of the x squared, no number after, just x squared. What does the most basic one look like? Let's start with the table of values. And I'm going to choose these x's. from -2 to +2. And that should give me an idea of the shape of the parabola. Although you guys already know what the shape's going to look like. So, if x is -2 and I plug it in here and I go -2 all squared, I get 4. If x is -1, 1. If x is 0, if x is 1, and if x is 2, 4. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And we see the sort of U/V shape. And I draw arrows on two ends because a parabola has two ends, just like a line has two ends. Because it could keep going up forever, and it could keep going to the right and left forever. This is the most basic parabola. From this parabola, we can graph other ones if we know this one. Okay. Certain vocabulary that goes along with quadratic functions. When we graph a quadratic function, we get a parabola. One of the main points on the parabola is called the vertex. Just take a guess. Which one of these that we graphed? No, you don't get to say. Because you did it, didn't you?
No.
Yeah, that. Okay. Sure. I believe you.
No, I know it's a little bit.
Water over the bridge. Under the bridge. No, over the bridge. Oh my. Easy as cake. Oh no, easy as pie. Easy pie. No, no, easy cake. It's a pie. Okay. Which one do you think the vertex is?
Like the top, like you.
Well, that's not really the top.
Well, the top of the thing.
The top of the thing.
Like the.
You're right. This is the vertex. I know, it's hard to explain. Right. So what we could call it is the turning point of the parabola. The turning point of the parabola. Culmination.
Yes.
Culmination of the parabola.
Yes.
Sorry, the turning points, not turning points. Okay. So, how do you find the vertex? It depends whether the parabola is right side up or upside down. If it's right side up, go to the bottom of it. That's the vertex. If it's upside down, go to the top of it. That's the vertex. So in y equals, and remember I could have put f of x squared, what's the vertex again?
0,
0, 0. The vertex is always a point. Okay? So that's the first thing. First word you should be familiar with when talking about quadratic functions and parabolas. The next two you are familiar with. The domain of any relation. Yeah, there's a lot of writing. Good for you, those characters.
Okay.
What's the domain of a function? All the x values. And the range? Y. And remember, there were different ways to show it. that we talked about last year. I'm going to use interval notation because I find it the easiest to use. So we'll review it. So in y equals x squared, the domain will be, let's go back to the graph. You remember how to find the domain. Domain is all the x values, which is horizontal. So it's all the points to the furthest left to the furthest right. What point on this parabola is to the furthest left? Negative. Doesn't it go past that? Doesn't it actually keep pressing like this forever? Negative infinity. And to the right? Positive infinity. Domain is really easy with parabolas. It's always this. Always. The domain will never change for a parabola, just like the domain of a line is negative infinity to positive infinity. Sorry, slanted line, I should say. Okay. The range, however, could change. So in y equals x squared, what's the range? Now you've got to change your thinking. What's the lowest y value to the highest? Lowest to highest. Yes. 0 to infinity.
Nice. Zero. I think that's.
You don't have to use the other notation, by the way. You don't have to know the other notation. Remember when we did the inequality signs and sometimes they had the double inequality signs? You don't have to worry about those unless some of you prefer to use them, which it's still correct. I just find integral notation generally easier to use. The maximum or minimum value is really what we're talking about. We're referring to the vertex. It's the y coordinate where the parabola maxes out or tops out. That's if it's upside down. If it's upside down, it's got a maximum. Because it has a point where it tops out. That point's the vertex, but we only refer to the y coordinate. Or where it's, and I'm going to put this in quotation because it's not an actual word, mins out or bottoms out. That happens when we have a right side up parabola. So depending on the direction of the parabola, we refer to a maximum or minimum, never both. It's one or the other. So going back to our most basic one, x squared, y equals x squared, does it have a maximum or minimum? Does it top out or bottom out? It has a minimum. And at what y value is the minimum? 0. So you need to say minimum at y equals 0. Don't just put minimum at 0. The minimum or maximum will always be the y coordinate of the vertex, always. Okay. Last one here, the equation of the axis of symmetry. Do you know, can somebody explain to me what symmetry is? When something is symmetrical?
It's the same.
Yeah, it's this, like if you divide it like that, it's the same on both sides of mirror images of each other. That's right. Okay. So, with a parabola, think about it this way. Where could I draw a line through the parabola so that it's symmetrical?
In the middle of the y-axis, yeah.
In this case, on the y-axis. This would be the axis of symmetry. So the axis of symmetry is always a vertical line. So the axis of symmetry is the equation of the vertical line that splits the parabola in half. So again, I'm just going to draw another. So if I had some kind of parabola hanging out in space, I would just draw the vertical line through that. It always goes through one point on the parabola. Always goes through the vertex, right? So always goes through the vertex. So what would be the equation of the axis of symmetry in y equals x squared? Well, how you write it, it's always the x coordinate of the vertex. So this case, x equals 0. You have to put the x equals. You can't just put 0. Because remember, the equation of a vertical line always begins with x equals. And if it's the y-axis, all the x values on the y-axis are 0. That's why we call the line x equals 0. So these are, do you have to be able to define these? No. Okay. But you do have to be able to identify them. So if I give you a parabola on a graph, you should be able to list all these properties for me. Okay. Now, this is the most basic equation, or most basic quadratic function, like I said, x squared. We could have numbers in front. We could have numbers in parentheses with the x before we square it. We could have numbers in the end, at the end. In other words, it could look as complicated as this. So there might be a number in front of the x squared. That actually does something to every parabola. It stretches it. Okay, we'll talk about that later. There could be a number inside parentheses with the x hidden squared. We call this h because that moves the parabola left and right. There could be a number after the square. That moves the parabola up and down. Okay. So the vertex form, using these, and these are the actual letters we use, okay, tells you, what do I want to say here? The vertex form tells you how the quadratic function changes from the most basic one. like I said, if there's a number in front, it's going to change the parabola in some way. If there's a number in parentheses with the x before the square, it's going to change the parabola in some way. If there's a number after the x squared getting added or subtracted, it's going to change the parabola in some way. And we're going to talk about each and every one of these. And actually, we're going to talk about these two right now. But just before we do that, okay, this is really kind of self-explanatory. How do you graph a parabola without always having to write a table of values? Well, think of the most basic one. Where was the vertex of the x squared?
0.
0, 0. What did you notice about the next 2 points going up from 0, 0?
0.
They went, how did we get to them? We went, how many across?
2.
1 across and 1 up, didn't we?
Yeah.
Come on. And then go back to the vertex to get the next 2. We went 2 across and how many up? 4. Which makes sense because if we go 2 across, we go 2 squared up. If we go 1 across, we go 1 squared up. So think of it that way. Instead of thinking of a table of values. Once you've got your vertex, you can get the other 4 points very quickly. Like if I said, here's your vertex. And what if I tell you it opens up? Can somebody come and draw the parabola for me? Yes. And it's important that I tell her that it's going up. Good. And finish it up. Yeah, it right, yeah. I know, it's acting weird today. Perfect. Thank you. Okay. So, and if I said this, I said this time it's going down. Well, I go 1 across, 1 down. And then back to the vertex, 2 across, 4 down. So once you've got the vertex, the other points are very easy to get. That allows us to not have to worry about a table of values. Okay. What happens when we have a quadratic function, x squared, but there's a number after it? Well, I'm going to show you. And I'm just going to show you by Desmos. Some of you don't even know what Desmos is. No, because actually I'm going to show you by a graphing calculator. Okay. So here, this is y equals x squared. X squared. Would you all agree?
Yeah.
Yep. Okay, that's y equals x squared. Notice on the example in your lesson, we want to graph y equals x squared minus 1. Watch what happens. Y equals x squared minus 1. What happened?
They're both down.
Yeah, it just minus, if it had a minus 1 after it, instead of starting here, it started 1 down. So what would you expect x squared plus 3 to start? Up on 3. That's it. That's it. So we don't even need to do a table of values. Because we just discovered that this is y equals x squared, move 1 down. So instead of starting at 0, 0, we start at 0, -1. And you guys know how to get the remaining 4 points. One across, how many up? No. One across, one up. Two across, four up. And that's x squared minus 1. So keeping in mind that graph. What's the vertex? What's the vertex parabola we just drew? Oh,
Oh, 0. Still 0.
no.
Oh,
What's the domain?
um,
Remember I said it's always negative infinity to positive infinity. The range, however, is going to change. What's the lowest? Y?
-1.
-1 to infinity.
Including, yeah.
So to get the axis of symmetry, it's always x equals. Here, I told you it's minimum. And remember, the minimum or maximum is always y equals. How do we find these numbers? The axis of symmetry will always be the x coordinate of the vertex. Always. The minimum or maximum value will always be the y coordinate. So if you've got the vertex, you've got these two things. And I've really talked about this, right? But we can see the size and the shape of the parabola of x squared and x squared minus 1 were the same, except it's identical, except we moved all the points in y equals x squared or f of x equals x squared down one. So as a summary, whenever we have quadratic function that has a number after the square, that's going to move it up or down. Okay? If the number is bigger than 0, so if it's like +1, +2, +3, +4, it moves it this many units up. If it's negative, it moves it down. Are you familiar with these bars? What they mean? Absolute value. What's the absolute value of a number? Oh. You can't give, so you know how to find it, but can you tell me what it is? The absolute value of any number is how far it is from 0. So what's the absolute value of 4? What's the absolute value of -4? Maybe you learned that in physics. Maybe not the distance from 0 part. But yeah. Okay. The vertex of the parabola will always be 0 for the x coordinate and whatever k is for the y coordinate. Like notice in x squared it was 0, 0. In x squared minus 1 it was 0, -1.
in x squared plus 3, it would be 0, 3.
The equation of the axis of symmetry is always still going to be x equals 0. So that's what happens if we have a number at the end. Again, what if I asked you this? Without doing a table of values or anything, can somebody come up and graph this for me? Remember, how do you start any parabola? Find the vertex. And then get the other 4 points from there.
There we go. Yes,
Yes. Good. Thank you. So remember, it's x squared up 2. So instead of starting at 0, 0, we start up 2 from 0, 0. And then we go 1, 1, 2, 4. You'll find that with practice, you'll be able to do these rather quickly. Okay, the last change, and by the way, the mathematical word is called transformation. The last change we're going to do is what happens if we've got parentheses x and then some number squared. So let's have a look again at Desmos. So we've got x squared. I'm going to get rid of this one. What was the one we want to know? X squared plus 2. Okay, so y equals x squared plus 2. Oops. No, not like that. Sorry. Yeah, my mistake. Yeah, I got to get rid of this. It's x parentheses plus 2. There. What did it do? 2 to the left. Where do you think x minus 2 would go? Right. But it's kind of reversed, isn't it? Like you think plus, well, why wouldn't plus, I would go to the right. And minus, I would go to the left. Because the reason for that is the vertex form is always written as a subtraction. Okay. Like what I said here, back here. Notice the way that I wrote it as a subtraction. That means if it's in subtraction form and this was plus 2, well, isn't x plus 2 squared the same as x minus negative 2? So h is actually negative 2, which means that we move to the left. Okay? So we don't need this. Okay? So this, if I were to write this as subtraction, it would be x minus negative 2 squared. So the value of the number inside is actually not 2, it's negative 2. So this means y equals x squared moved 2 left. So if it's minus, you move to the right. If it's plus, you move to the left, because plus is the same as minus minus. So that means, and we saw this on Desmos, and then we go 1 across, 1 up, and then we go 2 across, 4 up. So just remember, like a lot of students just remember, okay, I got to think the opposite when I think about that.
All right, let's have a look. Tell me all the properties.
Oh, -2.
What's that?
Oh, I thought it was one. Vertex is always like. Oh, I don't need it.
That's the one. Vertex is a point. -2, 0. Domain is always negative infinity to positive. What's the range of this one?
0 is going to 0.
0 with the bracket to infinity. And you should know how to get these other two. What's the equation of the axis of symmetry? X equals -2, because remember, it's always the x coordinate. The minimum value, so you don't have to state whether it's minimum, because it's already done for you, is
Y equals 0.
y equals 0. Gotta have that. So, what did we do? We moved y equals x squared, or sorry, we moved all points on y equals x squared 2 units left. So just to summarize again, this one. If h is bigger than 0, that means if h is like 1, 2, 3, 4, 5, but there's still a subtraction, we shift to the right. If h is less than 0, that means if it's -1, -2, -3, well, negative becomes positive, which means we shift to the left. The vertex will be whatever the value of h is, comma 0. And the equation of the axis of symmetry will always be the x coordinate of the vertex, or h. Finally, somebody want to graph this one? Come on. Come on. I only get 2 volunteers all the time. No one? Ah, yes. Thank you, Elsie. Beautiful. Hiccups. That's you move 2 to the right. Use the eraser. Hit the eraser button. Go back. No. Yeah, you're good. Okay, so that's your vertex. And the next points are there. Whoops. 2, 4. Right?
So 2 from
2, 4. Yeah, not 2 from the 1, 1. Good. All right. Thank you. All right, one more tester. Let's grab that one. Just combine your knowledge. Just combine your knowledge.
Or do you want to just tell me? Do you feel comfortable sitting in your seat and telling me? No, you can't tell me.
I know, I'm sorry, I'm trying to get out of this ball. Come on,
4 on X and then 3 and now it's 1, 1, 2.
perfect, thank you. I'm gonna miss.
Good.
Okay,
So we've done most of the transformations or the changes that x squared can undergo. The only thing we haven't looked at is what happens when there's a number in front. It does two things. It'll either flip it upside down, or it'll stretch it, or flatten it. So it could make it look like this, or it could make it look like this. But we'll talk about that next week. So for Monday, please. Exercise 2.1.